How's it going, you guys? In this video, we are going to be talking about exponential functions. Really, all that means is just that we have a variable in our exponent. Yeah, I know here we have a to the x, but we're going to assume that a is a number. So like here, this is the function 2 to the x, so 2 to the x power, that x is in the exponent. What that means, essentially, what happens is it's taking this number and multiplying it, multiplying 2 x number of times together. So like, if we put in a 1, that would be just 2 to the first, so there's 2. If we put in a 2, that would be 2 to the fourth. If we put, 2 to the second, which is 4. If we put in a 3, it'd be like 2 to the third, which is 8. But biggest thing, I want you to know that 2 right there, that is our base number. And the next one there, our base number is 4, so we'd have 4 to the x. So the bigger number we put in for x, the larger output we're going to have. Looking further, say even if we make like a chart for this, an x and a y chart. Say if I want to plug in like 0, 1, 2, 3, so on and so forth. And I want to look in the negative direction too, see what will happen. So if I put in 3 to the first, then 3 to the first is just 3. 3 squared is 9. 3 to the third is 27. So notice, as these numbers go up, they're getting bigger and bigger. So if I were to put this on a graph, it would go bigger and bigger. So keep going up exponentially. That's kind of what we mean when we're going up exponentially. It's an exponential function. Now looking in the negative direction, notice if it's going up and we're multiplying by 3 each time, when it goes down, it is dividing by 3 each time. So that would be 1, that would be 1/3, that would be 1/9, 1/27 would be 3 to the negative third. So notice it's getting really super close to 0, but it will actually never touch 0. Even if you do 3 to the negative 100th, or 1,000th, or 10,000th, or whatever, just remember, because of your exponent rules, that makes it 1 over 3 to the whatever. So it's going to get really infinitely close to 0, but never touch it. Exponential functions can also have a base that is a fraction. So here with the fraction base, what happens, say we do the same thing, negative 3, negative 2, negative 1, 0, 1, 2, 3. Anything to the 0 power is 1, so I know I have 0, 1. 1/2 to the 1 power is 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. 1/2 to the third would be 1/8. So notice those numbers are getting smaller and smaller. So if I were to put that on a graph, I would have 0, 1, and it would be getting smaller and smaller. So it would be going closer to 0 that direction. Now in the negatives, because I have 1/2 to the negative first, that is the same thing as 1 over 2 to the negative 1, which is the same thing because of our exponent rules, is 2 to the first. So this is like 2, and also the pattern is multiplying by 2 as it's going up. So that would be 4, that would be 8. So it's actually getting bigger in that direction. But what we call this one here, this one that I'm pointing to on the left-hand side, since it is growing, that is called exponential growth. Notice the base is greater than 1. Since this one is getting smaller, that is called exponential decay, because it is decaying away, just like your teeth. Whenever you drink all those soft drinks or eat the candy or don't brush your teeth, or whatever you do, it decays away to nothing, and then they have to pull it out, and then weird things happen. Oh, this was growth. Yes, that's like when you're growing right now. You cute little thing. All right, so looking at the graphs of these things, there's 2 different ways that we saw this. We saw one, when our base was greater than 1. When our base was greater than 1, it was when it was growing. So we have some graph like that, right? Because our base was greater than 1 when we had this function, 3 to the x. It was growing. When our base was less than 1, 1/2 is less than 1, it was decaying. So still going to cross through 0, 1, the y-intercept of 1, and it is going to decay as it goes on forever. Both of these graphs, since they do not ever touch 0, have what we call a horizontal asymptote, HA, at y equals 0. That is horizontal asymptote. It's not really asymptote. asymptote. Horizontal asymptote. An asymptote is just something that we approach. We are never going to touch it, but we're going to get closer and closer to it as it goes out forever. All right, so next thing we're going to look at says determine. Here we go. Determine whether each function is exponential growth or decay. We have some numbers out front. That's really our initial value, because if we plugged in like 0 for x, then this whole part would be 1, and we'd have 1, so the first value would be 6. But telling you whether it's growth or decay, I don't even care about that number right there. I don't care what it is. So the main thing I'm looking at is my base is 1/2 here. Since I have 1/2, this one is decay. I have nothing else to think about there. This one is 5/3. 5/3 is greater than 1, so that would be a growth. So now the next one that we have, -2 times 3 to the x. So now I think this 3 to the x, well, that is a growth, but notice we have a negative here. So what that negative does, if I think about the graph of 3 to the x, it looks something like that. But that negative multiplies our y's by a negative number. So this is actually making this graph go down like that. So this is actually a, we would think it would be a decay, but it's a growth still in the negative directions, because it's growing and growing. It's growing to a greater number. So that would be a growth. Sorry it took so long. This one, so now check this one though. This one has a negative x. So if I graph this function, this 1/2, poo, no. 1/2 usually looks like this. It's usually a decay. But what that negative on the x does is it flips it over the y-axis, because you're making your x values negative. So since we have a negative x, this actually flips it to something like that. So this is really a growth. Next thing we're going to be talking about is this letter E. This letter E. This E represents approximately 2.71. It's a number just like pi that we, I can't remember who it was that explored this number, but he was dealing with something called compound interest, and as he approached something compounding continuously, it was getting closer and closer to 271%. This is super important. All you really need to know though is that it's greater than 1. Since this base is greater than 1, that just means we are going to be growing exponentially, so that would be a growth. It's like a tumor. E to the negative x. So again, when we have that negative in the exponent, it's going to make it go the opposite direction, so that we would actually have a decay. All right, next ones we're going to be looking at is actually graphing these things, and we'll state some characteristics about them as well. So graphing 2 to the x minus 1. This is, as far as like moving it around, doing all that stuff, is exactly the same as what you guys have been doing. So it's super duper infinitely many times important that you guys know these two graphs. If you don't know these two graphs, you're going to be kind of out of luck, and you're probably not going to pass. So make sure you graph those things. So notice your base is greater than 1. If your base is greater than 1, you have a parent function that crosses at 1, and it is a growth exponent. Now, I have minus 1 with our x, so that takes everything and it moves it to the right 1. So I have this point moved to the right 1, and it is still being a growth exponential function. The other thing I want to see on the graph is your horizontal asymptote. We draw it as a dotted line. It gets closer and closer to that as we go. It's kind of hard to see right now because it's on the axis. It'll be easier to see later on. So for our domain, it goes left and right forever, so we have negative infinity to infinity. The range is 0 to infinity, sits from 0 all the way up forever. And we cannot touch 0, so that's why 0 is not a bracket. Our asymptote did not move up or down, so it's still at y equals 0. Moving on. All right, here. Again, know those parent functions. If you don't, you're going to be out of trouble. Or not, you're out of trouble, you're in trouble. So we have 1/2 should be a decay. So I will do something like that. I don't know what I said, but I said it. Move it left 2, and down 4. That's what those two things do right there. So if I move it left 1, 2, down 1, 2, 3, 4, that point is there. My asymptote moved down 4 and left 2 would be right there. I don't have no negatives or anything like that, so it's still a decay. and there would be our exponential function. As long as I see that point, the asymptote, and if it's a growth or decay, that's all I'm really looking for on these things. Domain still negative infinity to infinity. Now range, since it went down 4, it is all the way from -4 to infinity. And the asymptote, again, since it moved down 4, is now at y equals -4. Looking at our next pre-decay. All right, so since we have e to the negative x minus 2, again, our base is e. E is approximately 2.71, but again, all you need to know is that it's greater than 1, because I want you to be able to tell me that that is a growth exponential function. This negative, we are multiplying the x's by -1, or dividing by -1, either way, and then I'll move everything down 2. So in multiplying the x's by -1, what that does is it reflects it over the y-axis. It's a horizontal reflection. So it'll look something like that. And then move everything down 2. So down 1, 2. Move your asymptote down 2 as well. And graph your exponential decay function. Domain still negative infinity to infinity. Range, it moved down 2, so -2 to infinity. And asymptote is now at -2 because, again, it moved down 2. Got 2 more for you guys. You guys are doing good. Make sure you guys are writing this stuff down. If you're not, you're probably still not going to do very well. I'm trying to look out for you guys. I'm not trying to be like mean person. I just want to make you guys do well. I love you guys. All right, so we have the base, again, is e. E, again, is a growth function. Every time they're going to cross at 0, 1, no matter what. Because anytime you put in 0, you're going to have an output of 1. Anything to the 0 power is 1. So now this -2 on the outside, it's multiplying our y's by -2. So if I take this y value is 1 times -2 is -2. So what it does, it flips it over the x-axis. It's a vertical reflection, and it also makes it grow much faster. Last thing we have to do is move everything to the right one. So take everything, move it to the right one from where it is currently. So the horizontal asymptote will still be right there. I'm still going to get closer to it, and it is still a growth function in the negative direction. Domain, still negative infinity to infinity, so it's going left and right forever. So now range, notice it's gone on the opposite side, so it's coming from negative infinity all the way up until my horizontal asymptote, which is at y equals 0. Last one. Make sure you guys are writing down questions. I know it's hard to learn from videos sometimes, so come ask me questions. Don't just assume you have it. Make sure you guys practice. Do this stuff. I can't help you if you don't help yourself. So here, our base is 1/3. 1/3 is less than 1. That means I'm going to have a decay function. I don't know why I drew it as a solid line, whatever. That is not our final graph though, because we need to multiply our y's by -1. That negative on the outside is with the y's, so y's by -1. And then I need to move everything up 2. So I'm going to multiply my y's by -1, so that is a vertical reflection. So that reflects it over that line. Now I take everything and I move it up 2. I need a different color. I need a different color. All right, so take everything, move it up 2. So 1, 2. And again, the horizontal asymptote is now at y equals 2 since I moved it up 2. So it's a decay. So my domain is still negative infinity to infinity. The range now is negative infinity to 2, where my asymptote is. All right, and again, if you guys will, please tell me in all these, I didn't say it on all of them, but tell me which one is your final graph so that I know which one you want me to grade. As always, please, 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 a million times, come ask me questions. That's what I'm here for. I don't like sitting at my desk and just doing nothing. I like it when I'm able to help you guys. That's why I do what I do, because I love you guys. All right, I'll see y'all soon. Bye-bye.